Okay, so we talked about this and you guys said you were all on board as far as, yes, we want to try this. So I'm excited that you would at least give me the opportunity to do something different. What we're going to do today is called a flipped classroom. I'm actually going to give you your notes. Your notes are going to be actually your homework. And then we're actually going to use class time for you to be able to ask questions, work on homework, and let's just see what this is going to go. Let's start off, we're going to talk about complex numbers. Now, complex numbers have imaginary numbers, imaginary units, and then complex numbers are actually part real and part imaginary expressions. So, for example, you can see that I have 5 plus 2i. I is the imaginary unit. 7 minus 4i, that's an imaginary unit. You can also have radicals with these. Now, the imaginary unit that I mentioned is just the letter I. Now, I means two things, and you want to commit these to memory. I have it in this little think bubble right here. I equals the square root of a -1, and I squared is then equal to -1. And again, it's just easier if you commit that to memory. So, imaginary numbers. Those are numbers with I in them. How does the I get there? The I gets there by a process that we have kind of bubbled in around the I and the I squared. The -1 under a radical and then I squared being -1. Now, if you ever need to pause or write things down in the middle, feel free to push pause on the video so that you can get information like this. But let's go on because you can pause it on your own if you need more help. We have a few examples that I am going to put up here, and we are going to simplify. Now, when you simplify these things, you've got a negative under here. Up until this point, we haven't been able to work with a negative. So what we're going to do is we're going to use that imaginary unit to help us out. Hopefully, you agree that -1 times 64 is equal to a -64 under the square root. That will break up into a -1 times the square root of 64. This is your imaginary unit, the unit that we said we were going to commit to memory. And of course, you know the square root of 64, that's just 8. Now, proper etiquette tells me that normally we write our solution as just an 8i. Okay, so this is how it works out with a perfect square. Let's try it with a -28. Now remember, you are going to pull out that -1 first. It's very important that we get rid of that. And I'm left with a -1 times a 28. Now, break this apart into the two pieces that becomes. Now, I'm not changing the value. So make sure you don't change the value. The -1, square root of 1, turns into an I. And the 28 can be broken down further. 28 is the same thing as 4 times 7. 4 is the same as 2 times 2 times 7. Now remember, from when we reduced radicals, I don't have a calculator, so we're going to do it the old-fashioned way. For every two things that are the same, we get to bring it out normal once. So this 2 simply comes out, and everything else is still locked up where it was previously. So that's why the 2 is in blue. And then if I just rewrite this a little bit, I choose to write mine 2i radical 7. The reason that I do that is because some people like to write it 2 radical 7i. Now, the problem with doing it that way, do you see the I? It's really hard to tell. Is it under the radical or is it not? And even though that's proper form, there's still a lot of people, when I'm grading, I don't know if that I is under it or not. So this is a better way, especially if you're not real neat. And that's the way I would probably prefer to see it, is this way. But this is equivalent as long as it is very clear that the square root of 7 is with the radical, not the I. Okay? So moving on, we've got a fraction. Same thing, no big deal. It's still the same process over and over. This is a negative 1 times a 32 over 4. And I'm going to continue to break it up. That is an I times the square root of 32 over 4. Same thing, I square root of 32. Now let me think, that's 16 times 2. Those are the numbers that come off of the top of my mind. 16 is 4 times 4 times 2. And again, that's all over 4. Now remember, for every 2 things that are the same under the radical, we get to bring it out normal once. So I am going to bring my 4 out. I've got an I, and the radical 2 is still locked up underneath the radical sign. And of course, hopefully you can see that these two 4's are going to cancel. So that would bring me to my final answer, which is I square root of 2 over 1, or just I leave it I square root of 2. Well, what happens when you multiply them together? When you multiply them together, it's the same thing over and over, but you want to get rid of the I first. You do not want to multiply those together. You will not get a positive 24. So I am going to, first of all, take that negative 12 and make it a negative 1 times 12. On the other side, I've got a negative 1 times 2. As you can see, we have an imaginary unit here and here. So I'm going to go ahead and pull each of those out. And then I've got a 12 that's under the radical sign. And I also have a 2. So 12 is the same thing as 4 times 3. 4 breaks down into 2 times 2 times 3. Remember, for every 2 things that are the same, you get to bring it out normal once. I'm going to take my i's, and that is now an I squared. And I have a radical 3 and a radical 2. In other words, both of these things are locked up under the radical sign. It is okay to put those together. So in simplifying this, I squared, if you go back to the very first part of the notes, we said I squared is like secret code for the number negative 1. So if I squared becomes a negative 1, then the numbers around it all maintain their same integrity. 2 times negative 1 is a negative 2, square root of 6, and that is your answer simplified. And then we've got all these different variations of what we're talking about. Okay, so let's keep going. We'll kind of speed it up a little bit. Now the thing with imaginary numbers, you want to take the i's and put them with the i's. You want the numbers to go with the numbers, whether you're adding, subtracting, or multiplying. And in this case, I've got a negative 3 times an I times a 2 times an I. Now, if you group these two things together, you technically have an I squared. If you group these two things together, you get a negative 6. Except I squared, don't forget, that's like secret code for negative 1. Negative 6 times a negative 1 gives me a positive 6, and that's your final answer. Well, what do you do when you have more than just two things? Same thing. Just put i's with i's and numbers with numbers. So let's start with the numbers. I've got a negative 2, a negative 6, and a positive 3. All of those are coming down. Negative times a negative is a positive. So 2 times 6 is 12 times 3. And then I'm going to group my i's also. If I take these two i's and group them together, I get an I squared. If I take that final I, it's going to be all by itself. Now you can make this I to the third. There's a reason that I'm splitting them apart like this, because remember, for every set of two i's, or I squared, it turns into a negative 1. So 12 times 3 gives me 36. I squared is secret code for -1, and then the other I, there's nothing special about it. I just drag it along. Final answer, -36I, and it will remain with an imaginary number. So when you get something like number 7, where you've got a number directly outside of a parenthesis, same thing. You guys would normally do the distributive property. That's fine. Keep doing it. On your distributive property, I am going to take -5 times 1, which is -5. -5 times 2i is -10i. On this side, when you distribute, I like to draw the arrows just to remind myself, don't forget the second number. 3 times 3 is 9i. I'm going to treat that just as if I would an X or a Z or a C or whatever letter it would be. 3 times 4 gives me 12. I times I is I squared. Except, ding, 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 I squared. I squared is secret code for what number? Secret code for -1. So I squared is technically a -1. So let's fill in the rest of this stuff here. Do you see like terms that you can combine? I've got a -5, a -10 and a +9 gives me a -1i plus 12 times that -1. So let's continue to put this stuff together. -5 minus I minus 12. 12 times -1 is -12. Put your numbers together, normal numbers together, i's with i's. -5 and a -12 gives me a -17 minus I. And that's your final answer simplified. Okay, so now moving on to complex conjugates. A complex conjugate is just that real part and that complex part put together. A conjugate is in the form A plus BI, or keep in mind that it can also be A minus BI. Where A and B are numbers, I is that imaginary part. Remember, I is technically equal to the square root of -1. So things written in this form are called complex conjugates. One's positive, one's negative. They've got opposite signs. An example of that would be 3 plus 2i and 3 minus 2i. Another example of that would be -5i and +5i. Now you might look at this and say, well, Mrs. Martin, that's not in the A plus BI form. Yes, it is. Can't this be a 0 minus 5i and a 0 plus 5i? So technically the A part is 0. And then we can have any modification of that that we choose. So keeping that in mind, let's start simplifying by adding, subtracting. All right, so what do you do when you're adding and subtracting these things? Well, remember, you put i's with i's, numbers with numbers. So we have a 3 plus 2. 3 plus 2 is just 5. And then we've got 5i minus 4i. That's going to give me a positive 1i. That's my answer. It's that simple. Same thing with number 9, except be careful. Don't forget that you need to distribute that negative. So let's work that out and write it out first. 4 minus 6i minus 3 plus 7i. Now put numbers with numbers, letters with letters, and in this case we've got i's. So we've got a 4 and a minus 3. That gives me a total of positive 1. And then I've got negative 6i and a positive 7i. That gives me a positive 1i. So my final answer is 1 plus I, and that's in simplified form. Multiply, you do the same thing that you would normally do when you multiply two binomials. And divided by, we're going to use the complex conjugates to help us out. So let's talk about multiply. When I'm multiplying two binomials, I have to distribute. It's the same thing here. It's just instead of an x, again, you're using the letter I. 1 times 3 is 3. 1 times, don't forget, a negative 6 is a negative 6i. 4i times 3 is a positive 12i. And 4i times negative 6i, so a positive times a negative is a negative. 4 times 6 is 24. And don't forget, I times I is I squared. Now hang on, time out. Do you see this I squared? I squared is secret code for the number -1. So I'm going to replace any I squared that I see with the number -1. And then everything else I'm just going to copy. Now I've got like terms to combine, so a negative 6i and a positive 12i gives me plus 6i. And don't forget that you've got this 3 out here. And continue to combine and simplify like terms. Let's see, if I could get somebody to scroll this down, we'll keep going. Now, if I have a negative 24 times a negative 1, that'll give me a positive 24. So I have 3 times, hang on one second, let's get this moved down. Thank you. So, whoops, I lost my negative sign here. There we go, it's back. Negative times a negative is a positive. I have 3 plus 6i plus 24. Put your real numbers together. 24 plus 3 is 27. 27 plus 6i is your simplified answer. Same thing for number 11. Let's go on though, because I think you might have an idea here. The big thing is secret code I squared is really a -1. Whenever you see an I squared, you're going to pull it out and you're going to put -1. So let's continue on and let's go to the divided by, because that is something that we probably need to spend a little more time on. Okay, so let's look at something where we're dividing. Now you're going to have to use that conjugate concept that we talked about earlier, where they're opposites. Now the reason you want to do that is because you're not allowed to have an imaginary unit in the bottom of a fraction. Just like you cannot have a radical in the bottom of a simplified fraction, you cannot have an imaginary unit, a complex unit in the bottom. So we're going to have to use that idea of multiplying by the conjugate. Oh, hang on. How about I actually do the conjugate? The conjugate should be the opposite of what you see. So 2 minus 4i and 2 minus 4i. Now what's going to happen is you're going to multiply those. And I can put a parenthesis around there if it makes you feel better, because we're going to distribute. 3i times 2 gives me 6i. 3i times a -4i gives me -12i squared. All over. Do the same thing with the bottom. And again, if you want to put the parentheses on because that makes you feel more comfortable, go for it. 2 times 2 gives you 4. 2 times a -4 is a -8, and then don't forget your I. Do your inside terms next. 4 times 2 gives me 8. Don't forget the I. And a positive times a negative gives me a negative. 4 times 4, 16. I times I is I squared. So you notice, especially when I got to this last term, I kind of slowed down. I said, what's my sign? Negative. What's the number answer? 16. And I times I gave me I squared. But I see those I squared, so immediately I'm like, ding, 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 I squared, that's secret code for -1. So I'm going to take all the I squareds that are in here, and I'm going to switch them out. So 6i minus 12 times that -1. And on the other side, let's simplify at the same time. Do you see the -8 and the positive 8i? Let's get rid of those. They cancel each other out. And I have 4 minus 16. And don't forget, instead of I squared, we're using that negative 1. Simplify. Negative times a negative is a positive. So that's 6i plus 12 over. Negative times a negative is a positive 16. And we can just simplify a little further. 4 plus 16 is 20. Now at this point, you really want to put your form in standard form, which is a plus bi. So of that complex conjugate, let's work this out just a little bit further. Let's flip the order and separate them as we go. So 12 plus 6i. I took the top and I just flipped it, so the imaginary part's second. Now they're both over 20, so 12 is over 20, and 6i is also over 20. At this point, all you have left to do is reduce. I can take a 4 out of both of these. So if I divide a 4 out, I'm left with 3/5 on the left side. And on the right side, it looks like the maximum I can take out is a 2. And if I take a 2 out of 6, I'm left with 3i on top. Divide a 2 out of the bottom, and I'm left with 10. So this is standard complex form. The real part's first, the imaginary unit is second. This one we'll do the same way. Now I'm not going to work it out for you, but I will get you started. You have that 5i on the top. Excuse me, let me erase that. The conjugate is the bottom number. That's the one that we want to take the conjugate of. So 3 minus 2i, 3 minus 2i. So again, you're going to multiply this out on top. You're going to multiply it out on the bottom. And then you're going to get your answer. When you are done with this one, you should get 10/13 plus 15i over 13. Now, you guys, some people may argue, is this the same thing as 10 plus 15i all over 13? Yes, it is. But let me tell you, this is standard form that you'll use in math classes later on. So we might as well develop good habits and write it in standard form right away. So there's one that you can practice. Down on number 14, I will quickly, again, help you set that one up. But I'm going to let you work on that on your own as well. The big thing is identifying what is the conjugate. The conjugate is the bottom piece, and you want it to be opposite. Now remember, I'm going to think about this a minute. So I put my little think bubble out here. 5i is the same thing as 0 plus 5i. So what's the conjugate of 0 plus 5i? 0 minus 5i. You simply change that middle number. Now I'm not going to write the number 0, but I will take the minus 5i. And then you're going to multiply. So on the bottom, you've got a negative 5 times a negative 5, which gives me a negative 25i squared. On top, you're going to have to distribute negative 20i. Negative times a negative is a positive 5i squared. And then I think you know what to do from here. I'll give you the next step. And you are going to have to switch out the I squared, put in your negative ones. When you're done, your final answer should be negative 1/5 plus 4i over, actually you can write it one of two ways. You can put the negative down here. I prefer you not do that. What I would rather see you do is negative 1/5 minus 4i over 5. That's what I would prefer. So one more problem. Actually, maybe two if we can squeeze them in real fast. Let's take a look at solving. And I know this is a lot of information. We're going to take a couple days in class to go over this, so don't be overwhelmed. We're just kind of laying the groundwork right now. First of all, you should be looking at some of these numbers, and you should say, hey, I see a GCF. Always take out that GCF first. If I take out the number 3, I'm left with an x squared plus 16 equals 0. At this point, we can divide both sides by 3. Those go away, and I have x squared plus 16 equals 0. Move your 16 to the other side. Now, you can factor, but I found that people would rather subtract both sides on 16, and you'd have an x squared equal negative 16. So what do we do when you have an x squared? You undo it. Well, how? You undo it with a square root. And up until this point, we couldn't take the square root of a negative number, but now we can. So the square root of x squared is x. And don't forget, when you force the radical, you've got to utilize that plus or minus. And what I have is a negative 1 times a 16. The negative 1 is an I. The 16 is a 4 times 4. That's matching numbers. And actually, I'm just going to write it like that. For every two things that are the same, you get to bring it out normal once, and that's your final answer, plus or minus 4i. Now, if we have time for one more, we could use number 17. Now, number 17 isn't easy to solve like this is. It's actually the quadratic formula. So let's take a look at the quad formula. A equals 2. B equals negative 3, and C is 5. Everything you know from previous sections we're still using. Just like we've normally done, we're going to identify our A, our B, and our C so that we can plug into our quadratic formula skeleton. You know how much I like skeletons. And I'm going to put that up here. Opposite of B, plus or minus the square root of b squared minus 4ac all over 2a. Fill in your numbers that you're very used to and competent to do. There's my b value, my other b value, a, c, all over 2 times a, and work it out. X equals minus a negative. That gives me a positive 3 plus or minus the square root. Negative 3 squared is 9 minus 4 times 2 is 8. 8 times 5 is 40. So 9 minus 40 all over 4. Now work this part out first because you know it's like a parenthesis. And x equal 3 plus or minus the square root of negative 31 all over 4. Let's break this apart like we normally have, you guys. 3/4 plus or minus negative 1 times 31 over 4. That goes to I. So my final answer, 3/4 plus or minus I square root of 31 all over 4. And that is in standard complex form. All right, I think that's enough. So this will give us enough to get started in class. Try to go through it the best that you can. You've got another practice problem right here. If you're interested, let's see. The actual answer to this one is y equals plus or minus 2i if you want to do 16 for extra practice. Okay, good luck. We'll work on these tomorrow in class. See you in the morning. Bye.